In lesson 8, we're going to continue looking at equations and graphs, and this time we're going to be looking at writing the equation of a parabola. So let's take a look at this graph here, and without using the Pythagorean theorem, let's find the distance from A to the focus, B to the focus, and C to the focus. So determine that without having to do Pythagorean theorem, then come back to the video. So if we're looking at the distance from A to the focus, remember that's going to be the same distance as A to the directrix. So we should be able to just count from A straight down to the directrix, which is and you could count it 1, 2, 3, 4, 5 units, or take a look at the directrix being the point or the line y equals 0. And so then looking at the y coordinate of this point as 5 and knowing that that is 5. So the distance from A to the focus is also going to be 5. So then using a similar idea here, B to the focus. So B to the focus is going to be the same length as B to the directrix. You can again count that. Since the directrix is at 0 for the y value, and then this y value is 10, we know that will be 10. So this will be 10 as well. And then C to the focus should be the same as C to the directrix. So this one does not have any numbers in it. So how far is this point from the directrix? So it will be y minus 0 since the directrix is at 0. So this is going to be y units from the directrix. So then C is also y units from the focus. So what do we know about these two distances? We know that they're going to be the same. So whatever this distance is, this distance is. So you could call them D. We could also call them Y, since the directrix here is at y equals 0. So from 0 to y is y units, and then this one would be y units as well. All right, so then if we're going to write some equations here, so let's practice this before you get started. So these graphs are actually on page 53. So if you go back to the previous lesson, these parabolas are on page 53. So the equation for the ordered pair for the focus here is 2, 3. And then the directrix here is the x-axis, which is the line y equals 0. So if we're going to write the equation of any point on this graph, so if we just pick any point here and we just call it xy. So if we were going to write an equation here, we know that the distance from this point to the directrix, in this case, is y. Okay, we could do y minus the directrix line. So I'm just going to call that D for directrix. So this is actually equal to 0. So this is just going to be y minus 0 in this case, so just y. And then figuring out another distance that's equal to that. So we know this distance is equal to it, but we would want to write it in an equation. So getting this kind of Pythagorean theorem idea here with this little right triangle. So if we label this focus at 2, 3, then we know the width of this triangle. Remember, we subtract the x's, so x minus 2. And then this height here would be subtracting the y's. So y from the ordered pair minus 3 from the focus. And then we know that this blue segment is the same as this segment. So in this case, y units, because it'd be y minus the directrix of 0. So then you could do the Pythagorean theorem. So the hypotenuse, y squared, would equal the width squared plus the height squared, and added together from the Pythagorean theorem. So we should be able to apply that same idea here to this next one. Oops, and I wrote this wrong. This should be, the width was x minus 2. All right, so then we should be able to do the same idea over here. So the focus is the point 2,5. The directrix is the line y equals 0. So if we just pick any point on this parabola, label it xy. So the distance to the focus, okay, is going to be the same as the distance down to the directrix. So in this case, the y minus the directrix line of 0. So this y coordinate minus 0 is this length. And then we can set up the Pythagorean theorem again. So you do the horizontal and the vertical, that would connect those 2 points. So then this width is going to be the x minus the x coordinate. And let me label the focus on here, 2,5. So the width of this is going to subtract the x's, so x minus 2. And the height is going to subtract the y's, so y minus 5. And then we would plug this into the Pythagorean theorem. So c squared equals a squared plus b squared. So our hypotenuse here is y. Again, we remember that this length is the same as this. And then our legs are x minus 2, the width, squared, and y minus 5, the height squared. So then that's going to give us the equation of those parabolas. So then let's take a look at this one. So now write an equation that would allow you to test whether or not a point is on that parabola. So go ahead and write that equation. And then we'll talk about rewriting it in a different form as well. All right, so again, the length from, or the distance from this point to here, so from any point on the parabola to the focus, is the same as that point to the directrix. And the directrix in this case is the line, again, y equals 0. Okay, so we're at a y of 0. And so the length of this segment is y, meaning the length from any point to this focus on this parabola is equal to y. So then if we go ahead and plug into the Pythagorean theorem, so we have the hypotenuse squared equals the legs squared and added together. So the hypotenuse here, the length from the point to the focus is just y, so y squared. And then we can write the Pythagorean theorem to get this width and this height. So remember, the width of this is going to be where we subtract the x coordinate. So x minus 3 for the width of that triangle. And then the height of that triangle is going to be subtracting the y's. So y minus 2, and we would end up with this equation. And now you don't have to have parentheses here, so we could just have it as y squared equals x minus 3 squared plus y minus 2 squared. And this 3, 2 is the focus point. So then there's a different form called vertex form here. And that one only has our kind of x coordinate squared. It leaves our x minus h squared. So in this equation, it's leaving just this part. So let's multiply out the other pieces. So we're going to leave it as y squared for now. And we're also going to leave it as x minus 3 squared, since this part is still in parentheses and squared here. So this one is still left as a binomial. So let's multiply out this y minus 2 squared. So remember that that's going to be y squared as the first term. We're going to have negative 2y twice. So we're going to have negative 4y. And then we're going to have negative 2 squared, which is plus 4. So then we want to get the y's on the left-hand side. So we're going to bring this y squared over. So I'm going to subtract y squared from both sides. So we'll get 0 equals x minus 3 squared. This is also 0. Y squared minus y squared is 0. So we still have that negative 4y plus 4. So then let's bring this this negative 4y to the other side to get all of our y's on the other side. So 0 plus 4y is 4y. And then we have x minus 3 squared. Negative 4y plus 4y is 0. So we have the plus 4. Then if you look in this equation, the y is by itself. It doesn't have a number out front. So we are going to divide by this 4 to everything. Okay, so to both sides. So 4 divided by 4 is 1. Then we have this x minus 3 squared divided by 4. And we have 4 divided by 4. So the way we're going to write this first one is thinking about having a 1 out front here. So we're going to write this as a fraction of 1/4 times the x minus 3 squared. So you can kind of see this 1/4 happening. And so we're just going to write 1/4 out front. And then 4 divided by 4 is 1. So then this is called vertex form. So we had that as a times x minus h squared plus k. So then we're getting a vertex of 3. So x minus 3. So the vertex is 3 and then 1. So if we go up here, then we can check that out on this parabola that the vertex is 3, 1. So we used the focus to write it, and then we went to vertex form and got the vertex. All right, so taking a look at both of these, there's an x minus 3 in each equation. So what does this mean? So this one's actually giving us the focus, okay? So we used the focus in here. And so the focus that we plugged in was 3, 2. This one is giving us the vertex back. And the vertex we're getting here is 3, 1. So this is telling us that the focus and the vertex always have the same x coordinate. Okay, so we never touched this. So that focus and vertex always have the same x coordinate, and then their y coordinate is going to change. All right, then take a look at these graphs on the screen and go ahead and match each graph with the equation that it represents. You can just pause the video, look at the screen, and match those. All right, so let's take a look. So all of these are written with the focus, okay, and we can tell because it's equal to the y squared, okay, versus the vertex form was y equals a times x minus h squared plus k. So only the x part was squared. So these are both in, or these are all in focus form. So let's take a look at the focus in each one. So in each of these, the focus is, so this one is 3, 2. This one is 3, 1. negative 3, 2, and 3, 2. Then we can also look at the directrix. So remember, the directrix helps us get the distance or that C value when you're doing the Pythagorean theorem. So it's y equals 0 in these first two, y equals 1 in this one, and y equals negative 1 in this last one. All right, so you can probably figure out that this one that has a focus of 3, 1 goes with this one since it's the one that plugs in a 1. Okay, so this graph number 3 went with equation D. Then we've got one so this one had a directrix of 0. Okay, we've already used that one. So now this one is the only other one with a directrix of 0. So it's going to just be equal to y, right? Any point on here is just going to be equal to the y coordinate since the directrix is at 0. So equation A goes with graph number 1. So then a couple options here to figure out graph number 2 and 4. So you've got a different directrix, right? So the x coordinate here is negative 3 versus here is 3. So remember, we do x minus the directrix coordinate, okay? So whatever letter we want to call that. But so x minus that x coordinate. So x minus a negative 3 is going to end up being x plus 3 in here. So right here is the x plus 3. So graph number 2 had to go with equation C, which leaves 4 for equation B. Another way would be thinking about the distance from a point to this line. So again, you'd be taking the y coordinate on the point here, which we don't know, and we'd be subtracting the directrix. So taking a point here and subtracting the directrix. So again, for this one, it's going to be y minus negative 1. Which would turn to y plus 1 as what it's equal to, versus graph 2, y minus 1 for that distance. All right, so how is Pythagorean theorem related in parabolas and in circles? So remember, that's what helped us get the distance, because in a circle, the distance of all of the points is equal. So any point on the circle is equal distance from the center. So all of those are going to be equal. So then we could do Pythagorean theorem by figuring out the width by subtracting the x's, the height by subtracting the y's, and then the Pythagorean theorem would give us that radius, because we know the radius stays the same. Then in a parabola, the distance from the point to the foci, okay, so this distance here is equal to the distance from the point to the directrix. Okay, so in this case, the directrix is 1, so the y, or the height minus the directrix, would be the difference there. So this piece here, okay, this hypotenuse is equal to y minus 1. And then we would set up the Pythagorean theorem equal to y minus 1 squared. So the distance changes, okay, because if we're going to this point, that's a different distance, but it's still going to be the distance, to the directrix. Okay, so those two blue lines there would be equal. So we know that this height is the y value minus the directrix. That's the same distance here. And then you could set up a Pythagorean theorem to equal that y minus 1 squared. So the distance is always y minus 1 squared, and then setting up the Pythagorean theorem. All right, so then here is the summary. So we've got a parabola as the image that consists of all points that are the same distance from a point and from a line. That point being the focus, the line being the directrix. The distance from a point to the directrix, okay, is y units when that directrix is y equals 0. So then the distance to the focus by definition must be the same. So the green solid line and the green dotted line are the same distance. Okay, so we know that this height is y, so this distance is y. Then we can figure out the lengths of these legs by subtracting the x's to get the width, subtracting the y's to get the height, and then doing Pythagorean theorem to get this equation. And then here are the steps to get it into vertex form. So we're going to multiply out the y squared portion, or the y portion. Okay, so we're going to multiply out the y binomial. Then subtract the y squared to get it equal to 0. Then in this one, they brought the x minus 1 squared and the 16 over to the right side. So we isolate the y. So you just have the y left. Then divide by the -8 to both pieces. Here you have -1 divided by -8, which gives you that +1/8. -16 divided by -8 gives you that +2. And then your vertex in that one, okay, would be 1, 2. So what are you subtracting from x? 1. And then what are you adding? 2. So here's a cool down for you to try. If you're struggling, be sure that you reach out to your teacher to ask for some help.